Hey there guys, my name is Hill. I'm a rig welder with Legion Piping Fabricators, and we have a big duplex job here at the Nisku Alberta shop. A lot of duplex here, a lot of duplex.
Check out weldlive.com and shop all welding gear shown in this video.
Okay, so today we have Eli, our lead welder here, doing a welding duplex. It's 2205 duplex using 2209 filler metal. And with these alloys and exotics, we'll be using a purge monitor. I have a Huntington Fusion, and this one here belongs to Eli here. It's the inner purge. And you see these numbers here. These purge monitors are, they're the desktop models, so they're very, very precise. These read 999 parts per million and less. So they're meant for like, say like a titanium, duplex, super duplex, nickel alloys kind of thing. So Eli is striving for, it depends on what the client wants for cleanliness of the oxides. If you go to 25 parts per million and less, so this will read 25 parts per million, then you'll have no heat tint, you'll have nice silver. There's no heat tint. There's not enough oxygen in the pipe itself to form any oxides because it's not enough oxygen to interact with the weld puddle as it elevates in temperature to form oxides to protect the metal. So you'll have no heat tint. If this thing reads say like 30 to 60 parts per million, you'll start getting light straw color. You'll get some yellows. It'll start going up to like 60, 80. You'll get some brown colors. You'll get some golds. You go past 100 parts per million, you have like blues and purples and beyond. So if it's really detrimental, you get a really terrible purge. You'll start, especially on nickel alloys, say if we were welding a nickel alloy, when you're beyond 100 parts per million, you'll see like little pepper flakes. You'll see kind of like a skin floating on the weld puddle. It gets to a point where the oxygen inside the pipe is so bad that your bevels will start dissolving in on itself, and it's just going to be a terrible purge. So on this duplex, we're striving for essentially less than 25 parts per million, 30, 40 around there, light straw color, that's acceptable on the duplex here for this client. So if you look at the technique here, Eli, he's just walking the cup, and he's using a nice dabbing technique. So that kind of, he essentially opens the keyhole. He's walking, he opens the keyhole, and then internally inside the pipe, it goes liquid, and he just dabs onto the leading edge there, and the weld puddle just gets taken from the filler metal and it just sucked in, and it fills up the keyhole. It makes one ripple and it keeps going. Very fast, quick, efficient speed here. Very quick technique. And you can see nice heat affected zone here. So he'd be using I believe it's a 332 filler metal. It's a very nice, precise technique, depending on the gap and land and everything that's on there, but it should be a feather's edge, minimal gap. So Eli's welding at about 12 o'clock. Now on this piping, it depends on like the gap and other misalignment and other things you can deal with. He's at 12 o'clock, so he's going to have a nice uniform root pass, nice deposition at 12 o'clock. If it gets to a point where the gap is starting to close up and he needs to get more penetration, then you'll be welding slightly more uphill. And if you're welding at that point, you'd be better off standing like this and walking away from yourself. Whereas depending on if you have a wider gap or misalignment, other kind of things, it's better if you have the torch this way and you're welding, pulling the puddle towards yourself, and you're at 12 o'clock and slightly downhill. If you weld slightly downhill, you have a nice flat root pass. If it's doing, let's say, a stainless steel, then you'll have a flat puddle, but you might get a little bit of a line, a little bit of suck back. So a person has to be conscientious of where they're welding on this particular material. So Eli is putting a really nice hot pass on. He's using the 332 filler metal, making sure it gets nice in the groove and the gap in there. It has a really nice gold color to it. So what Eli will be doing is he'll do this hot pass on there. The duplex, the max interface temperature, according to the welding procedures, is 300 degrees Fahrenheit. So as you can see, Eli has a very nice purge going. He would have started at about around 25. You know, it would have been a good purge. And then when you have the root pass in, and the root pass is fully completely finished, the parts per million of oxygen on the hot pass drops down to less than 11 parts per million. And the way it works, say for example, if you have any heat tint on your root pass, the root pass would have been done at anywhere from 25 to 30 to 60 parts per million of oxygen. So even if you had any amount of heat tint, you know, light straw colors, gold, brown, etc., when you put the hot pass on, the hot pass drops down to 11 parts per million or less. It's a really good quality purge. And it has a wider heat affected zone. And when you put the hot pass on, it has a wider, wider heat affected zone. It heats up more of the material. So it is actually, and a better quality of purge, so it actually takes and absorbs, and it just sucks out a lot of the heat tint that is there. So you end up with a really nice, if you get light straw color or even no heat tint at all, you get a really nice quality purge. This is something that's really noticeable in titanium, but other metals as well, like a stainless, duplex, etc. It's just because of the purge quality gets better and better, and the wide heat effective zone. So it kind of cleans up whatever's on the root pass. You see, walking the cup offers us a very, it's almost like a robotic movement. One of the things at Legion here is that all the welders, even in the skill proficiency test that we have, all the welders need to learn how to walk the cup on the root pass, filling and capping. Even something like a 2-inch skid 40 carbon steel pipe, we still walk the cup on the root, even if it's a position weld. It's all to do with aesthetics, production, aesthetics, and it's just more robotic. It offers a higher quality weld, less voids, less defect. It's a very constant movement, very continual robotic movement. So these exotics and alloys, so carbon and chrome, for the most part we'll do a TIG root pass, possibly even a TIG hot pass depending on the welding procedure, and then we'll use stick for fill and cap. When it comes to stainless alloys, duplex, super duplex, nickel alloys like Hastelloy, Monel, Inconel, copper nickel, titanium, aluminum, we'll do TIG all the way out. Many years in the welding industry in Alberta, it was all solely based on production. You have a stainless steel pipe weld, for example, that would be a TIG root, and if not a TIG root, then it would have been modified short circuit root pass, and it would have been stick fill and cap. Stick welding on stainless is not very aesthetically pleasing. It's not very attractive, and it's a little bit tricky. But essentially, it's not a pretty weld. It's not as pretty as TIG welding, but it's productive and it's fast. But when Legion came along, we had TIG on everything. Everything's TIG welded. Higher quality, much higher quality, higher aesthetics. We offer very, very pretty attractive weld. And that's essentially dominating the industry now, is aesthetics. But also we do have the production, because we are able to get a lot of this welds out. Something like a 52-inch 688 wall 304H stainless steel pipe will be TIG weld all the way out, and we can get those things out pretty quickly because there's a lot of techniques that you learn from TIG welding to get a lot of quality fill, to be more productive, more efficient, more faster. And the cap pass being very aesthetically pleasing and robotic, walking the cup, it just looks like a really high quality product at the end of the day. Hey there guys, thank you for watching the video here. Our lead welder and also a welding supervisor moving down to Houston, Texas there, did the welding here, 10-inch schedule 40. He's going to be moving on to the next large size pipe. If you like the welding videos that you see here, you can follow on Instagram and YouTube for Weldtube. And also if you like the welding helmets that we're welding, also the welding helmet that Eli was wearing, and this one here, weldlife.com. Thank you.